Alright, so the warm-up, it says to, without looking at any notes or the textbook, write all three forms of the quadratic, standard, vertex, and intercept form, and the formula for the axes of symmetry, or axis of symmetry. Alright, so, does anyone know? Yes?
You want the vertex?
So it's a standard, all I have is negative associated.
Or what? What is that? Negative b over 2 has something. What is that? Formula for Alright, so you have something that the formula for finding the axis of symmetry, x equals negative b over 2a, good, and that's for standard form, good. Yes?
Y equals ax squared plus bx plus c.
Good, that is standard form, good, yes?
Y equals a to thing x minus 8 and then plus k.
Don't forget the squared. Yeah, don't forget the squared, good. That's good, that's the vertex form. We're gonna see all of them in a second. And yes?
I got part of it. It's the intercept form. It's something times x. Wait, x plus p times x plus k.
Close. Yes? Beautiful, perfect. That's intercept form, yes.
X equals 3 p plus q divided by 2.
Okay, now that relates to intercept form, and what is that?
Axis.
That's the axis of symmetry. So we're gonna go ahead and see, look at all these on the next slide over.
I have a question. That was like some participation right there, huh?
Usually, if you're humble, that's probably better. But I appreciate participation. It's definitely be considered, because at the end of the year, there's going to be a significant portion of your 20% class, employability and so forth, will be determined by how you behave in class. So, all right. So here are the forms that you must know. Okay. So we have standard form, which is, and I don't care capitalized or uncapitalized, not a big deal. Y equals ax squared plus bx plus c. Vertex is y equals a parentheses x minus h squared plus k. And intercept form y equals a parentheses x minus p plus parentheses x minus q plus parentheses. And we're going to go over all of these, and we'll go over as much as we can because I want you guys to do well on this test. So we're going to make sure we go over as much as we can. No, this is not an open notes test. Taking notes allows you to learn because when you write something, you tend to memorize it better. Note taking is also good because you can study those notes later.
I never look at them.
Is that cute?
What is the f?
What is the F? Okay, we'll get there in a second. So just on the blue for right now, definitely be comfortable with these. I know we haven't. Can you please quit talking and talking? So we definitely have intercept form is what we spent the least amount of time on, but we definitely should know standard, vertex, and if you haven't memorized intercept yet, go ahead and do so. And we'll talk about these three. Are you good, Dorian? You haven't memorized? Okay, this is what I remember. This is what I see. This is what I see typically. So let's do our best. I want to see focus, attention. Let's not use that language, banging. Don't use that language.
My bad.
All right. So this is your review. So here we go. So standard, when you have it in this form, the axis of symmetry is x equals negative b over 2a. So whatever this is, the opposite of it, over 2a. Make sure that your form matches this form perfectly. It's plus bx plus c. Okay, so it sounds like some of you have this memorized. All of you need to have it memorized. X equals negative b over 2a. Now, if you wanted to find the y-coordinate of your vertex, you simply just plug that into whatever the function is. So let's say, for example, x is equal to 3. you simply plug in that 3 into this x here and this x here. And then whatever that simplifies to, that would be your y value. That would be the y value of the vertex.
What should I get the bottom? What if I have short-term memory? Like, how would I be able to?
Let me skip this.
So standard form again, x equals negative b over 2a. If you want to find the y coordinate of anything, if you're given the x coordinate, you plug it in the original function. That's this whole essence of the functions. This is a relationship between y and x. You give me x, this guy says, okay, here's what y is, no matter what point it is. So don't get carried away with how technical or mathematical this looks. All is the same. If you know what x is for the vertex, plug that in to get the y. And then you will have the coordinates of the vertex. And that's true for any point. You have the x coordinate at some point, plug it in and get the y coordinate. Vertex form. Vertex form, when it's written like this, now notice it's a x minus h squared plus k. The x equals h is the axis of symmetry. Because the vertex is hk. So every single one of these, the x coordinate of the vertex, that is the axis of symmetry. The x coordinate of the vertex, that is the axis of symmetry here. I'm going to go ahead and erase the form. What was your question?
The F, what is that for?
The f, that's like, if this were like f of x, it's saying f of whatever negative b over 2a is. Whatever that is the y coordinate. Right. Try to focus. If you're struggling with this, try your best to soak in as much as you can. All right. And we also have other videos that you can watch from the past, as well as other PDFs of these flip charts that go over this. Vertex form, hence its its name. It's nice and convenient. HK, again, axisymmetry x of h. Anyone have any questions about vertex form? I think this is probably the most straightforward, most simple one. And then intercept form, that's the newest one. When you have written like this, then it's just saying that, okay, these p, if I insert that x be p, this would become 0, the whole thing would become 0. So p is an x-intercept. If I let x be q, I would have q minus q, which is nothing. 0 times anything is 0. That would be the other 0. So the p and the q, they are the zeros of this equation here. Yeah, we did do a practice problem, and I'll go ahead and pull it up now. So if we look at here's one that we did. We had y equals x minus 3 times x plus 4. I know this is a lot on one page, but let's go piece by piece. So let's do this, because this is the one that we've had the least amount of practice on. So, what's that? Do I want you to write it down? I want you to do well in this class, so you do whatever you have to do. Typically, at the high school level and up, middle school level and up, you usually write down as much as you can when you're having a lesson. So if we have y equals x minus x plus 4, if you don't feel like writing it down, again, this is available in PDF format on Blackboard. So y equals x minus 3 times x plus 4. This is intercept form. It looks like it, right? X minus p, x minus q. Where a is 1, if a is not written, it's understood to be 1. So the zeros would be, well, what would make this equal to 0? If x were 3 or if x were negative 4. So those are the zeros. The zeros are x equals 3 and x equals negative 4. You can just say the zeros are 3 and negative 4. They're called zeros because they make y equal to 0. And they're also called the intercepts. They're called the x-intercepts. Because that's where y equals 0 is right here, right? Y equals 2, 4, 6, 8, 0, negative 2, negative 4, going down. So, when you're presented this and you're going to be presented each one in its correct form. You don't have to do any manipulation. When you're presented a problem like this, for intercept form, you plot the x-intercepts first. Now that's a little different than how we did standard and how we did vertex, where you plot the vertex first. For this one, because it's the intercept form, you plot the x-intercepts first, hence maybe why it's called intercept form. That's the information it gives you right up front. Okay? So now the rest should be intuitive. This part here, don't let it bother you that it looks like a strange looking formula. I know you guys have had to memorize tougher ones with the quadratic formula, and even Pythagorean theorem. But here, why is it P plus Q over 2? Why is that the axis of symmetry? The reason is because if you know that the intercepts, if you know that they're these right here at -4 and 3, and you know that all these parabolas that we've looked at have been, exactly concave up or exactly concave down, it should make sense that the vertex is halfway between these 2 points horizontally. That's why it's P plus Q over 2. To understand intuitively, it's because it's halfway. When you get the average of something, it's going to give you the halfway mark. So when you add 3 and -4, you get -1. -1 divided by 2 is -1/2, so that is the axis of symmetry. That's why it's the average of P and Q. And then you just have to find where the vertex is. You know that the axis of symmetry is going through the middle, but how do you know exactly where this point is here? How do you find that? Again, you know that -1/2 is the x coordinate of the vertex. How do you find the y? Plug it into the original function. That's how you find the y coordinate of any point if you're given the x coordinate. Because that describes the relationship. Y is this when x is whatever. So we got -1/2. I plugged it in. You can see the math here, just doing something with fractions, addition, and multiplication. Just make sure your addition and multiplication of fractions is solid. If you need to practice that, do so. Then you get -12 and 1/4 for the y value. Here's a good example too. I didn't really have enough room if I did each one of these as 1. So you can specify, you can change it and make your delta 2. Make each jump 2 as long as you specify it and write it down in case you were to run out of room, which I would have if I kept it as 1. If I say, you know what, I'll just make it 2 so that way I can fit it on here and I can redo my whole graph. Nothing wrong with that. So then I plot this point. I plot the vertex, which is written here in purple, -1/2, -12 1/4. Once I plot that, 3 is good enough. If you can do 5, go ahead and do so, but for this particular graph, I think 3 looks good. Minimum of 3 points. If you can do 5, do it. And then we talked about the domain and range, which we can talk about in a second. Any questions thus far on this? Please, this is your review. I want you to do well on the test. Anything specifically about this where it gets fuzzy, or you want me to repeat something I said? Yes.
Like, I don't like, is that okay to talk like a range? What did you find? I still don't know.
Okay. Let's establish this. Does this look like this form here?
Yeah.
Okay. So that's good. So you know when you're given this on a test, okay, this is the intercept form. Okay, it's the intercept form. It's called intercept form because immediately from here, I can find my x-intercepts because of the way it's written. Don't you see if x were 3, y would be 0?
Yes.
And do you see if x were -4, y would be 0? So I plot those, -4 and 3.
Okay.
That's that step. Then once you've established that, you don't necessarily have to worry too much about this. You should know it, it's not that complicated. But in case you forget this, let's say for some reason between today and tomorrow, or everything up until now until tomorrow, you forget this. Just know intuitively, if you have 2 points that are on the same level, we've noticed all these parabolas are perfectly up and down, or perfectly concave up, or perfectly concave down. We've dealt with none of this thing where it's been shifted like this. We've dealt with that none at all. So I know that my x coordinate, my vertex, has to lie halfway between here. No matter whether it's way down here, or here, or here, or concave down up here, it has to lie on this axis of symmetry, which is what? Well, it better be halfway between these 2 points. because these 2 points are on the same level. That's why it's this. That's why it's okay, add them up and divide by 2. Add up your zeros and divide by 2, and that'll give you negative 1/2. Boom, axis of symmetry, which also is the x-coordinate of your vertex.
And how zeros would just be -3 and -4?
I mean, positive 3 and negative 4. Negative 4 was a 0 and positive 3. Because those, they're called zeros because they are what make the function y value equal to 0. Yeah? They're called intercepts because obviously that's where this function intercepts the x-axis.
So just add them up. You get your-
Yeah, so to find what's between them, where exactly the axisymmetry will run, you find or take their average, add them up, divide by 2. You'd have their average.
Okay.
Any other questions as far as this? Again, this is your review. If you're not getting it, this is the time to ask. You can ask anything about this as long as it's related to this. Please do so. Jonathan, are you okay on this? Okay. Diamond? Where did I get what from?
The point.
These 2 points? These 2 points? These 2 points? These I got from here. The fact that if I let x be 3, it would make the whole thing 0. Or if I let x be negative 4, it would make the whole thing be 0. And you're going to be given it, again, in simple, it's going to be given in the form all ready to go. It's not like you have to, oh, first factor this and then do using the intercept form. No, it's going to be given to you like this. And if a were 3, 4, negative 10, it does not affect the zeros, right? If I had an a value of 3, for example, it would still be true that the zeros are 3 and negative 4 because 0 times anything is 0. So the a value does not affect these values here, what they are, the x-intercepts. What's that? A is 1 right now, technically. I mean, I could write a 1 in front. It's not 0, because if it were 0, this whole thing would be 0. So it's a is 1. I mean, I can even write that too. Technically, there's a 1 in front of there.
Like, I don't know why you didn't start, why you didn't start 0 with the vertex.
Why did I start with what?
0.
What do you mean start with 0?
We got the dot one right now, why you didn't start it with 23.
Start with, do you mean this axis of symmetry?
Oh, the first vertex way down at 12.
Yeah, my vertex is at negative 1/2, negative 12 1/4. Yeah? I got that from this formula here. Right? This is the one, again, where you actually start with the x-intercepts. That's the first thing you do. Then you can find the vertex. The other two, you find the vertex first.
Okay, so like, where did you get the numbers that said 0? I'm trying to figure out what the numbers
They're the zeros. They're what make this guy 0. 3 and negative 4. So 3 plus negative 4 over 2 simplifies to negative 1/2. Any other questions? Big question? Yes. Okay, so now we're going to move on. There's no more questions about what we talked so far. So domain and range. So you have to know domain and range. So review of domain and range. Again, the definitions are available also in another flip chart. But domain, anyone remember what domain is? Domain is all the possible values for x, because that's our independent variable. And range, therefore, is all the possible values for y. No matter what your parabola is, the ones that we're working on right now, the domain is always all reals. No matter what parabola you're working on, whether it's concave up, concave down, if I scan all the way left to right, there's no value of x that doesn't work. That's not part of this function. No real value. That's not part of this function. The only one you really have to worry about, the one that's not all reals, is going to be the range. Because if you look at this, and again, just focus on the blue graph here. If you look at this, y can't be negative 13. Y can't be negative 15. It can't be negative 20, and so forth, going all the way down to negative infinity. The smallest value that y can be is negative 12 1/4. And you don't have to write it like this. I'll show you both ways. So bracket says including negative 12 1/4, because that's actually we have a point there, all the way to infinity. Notice there's no restriction in this way, right? This thing keeps going, opening up forever and ever and ever, so it makes sense that it goes to infinity. I don't care if you write it like this, or if you write it like this. all reals greater than or equal to negative 12.14. Either way, same for this guy. You can just write all reals, or you can write, if you like an implementation, negative infinity to infinity. I will accept either answer. Any questions about domain and range?
You will ask us, well, this will be on the test, correct?
What's the question?
This will be on the test?
Yes. Yes. You will have to, on part 2, you will have to graph each of the 3 functions. Part 2 will be on Wednesday. You will have to graph a function given in standard form, given in vertex form, and given in intercept form, and then give all the information. But they all have similarities because they're parabolas. They all have the idea of, okay, it's going to have a min or a max, depending on if it's opening down or opening up. If it opens up, the vertex, the value of the vertex, that's the minimum value. If it opens down, then we know that the value of the vertex, that's the maximum value. So the minimum value of this function is negative 12.14. Diamond, please stay awake. And that is it. So you have to know vertex, axis of symmetry, domain range, and then a max or min value. Anyone have any questions about this one before we move on to another problem? Again, I don't mind repeating this. This is your review. I want you to do well. So if anything's still fuzzy, I don't care who asks. You have the right. You have the right. Anyone else to ask questions in here? All right. So I'm assuming everyone is good on this. So then now what we're going to do is we're going to go back to. I think we left off on that problem. I believe the problem I just looked at. So this is the test. So this is the test. The test is on Tuesday you have part 1. You have to solve a 3-variable system. There's only one problem like that. Okay. If you want to look at the solutions to the quiz 1, which was solving 3-variable system, it's available on Blackboard. I posted it last week sometime. You can see how I work it out in case you need a review. There's one problem that's solve a 3-variable system. It's going to be worth a significant number of points because it takes a lot of work. So make sure you can go as far as you do the best you can. Yes. Yep. The solutions to this, I actually have it now a section that's quiz solutions, quiz/test solutions. You can see quiz 1 how I've solved every single system. All this stuff is on Blackboard. I give it titles that are appropriate. Like you'll have a title that says, for example, transformations, whatever, or slope, standard form of a quadratic, or vertex form of a quadratic. So you'll see the ones that are relevant. Okay, and we also have one of these from the past too that you can go over. So you have the solutions to quiz 1. You also have on Blackboard the flip chart that relate to this way back when. So. These were the 2 that I guess period 1 wanted to focus on the most. We don't have to focus on those. We can focus on whatever you guys want to focus on, but you need to know solve a 3-variable system. There's one problem with those. You have to know how to describe the transformations of given parabola from its parent function. All of these are given in vertex form, which is nice. I think it's convenient. They're in the form that's nice and easy to understand, where you can just clearly see what's what. There'll be 3 of those problems. Then another part, you have to write an equation to show the transformation. So they read you the transformation. So you hear a problem like this: translated left 4 units, up 1 unit, and vertical shrink by a factor of 1/3. They write that out. You write the equation. And then lastly, graph a function in standard form, vertex form, intercept form. We just did one of those. We did intercept form on the previous problem we just did.
Wait, so we have 2?
So we have one problem with this, 3, 3, and 3.
No, this is Tuesday and Wednesday, so it's 2 days.
Yep, so this is a 2-part test. It's a test. We only have 45 minutes of class. So on Tuesday, this is part 1, and then part 2 is Wednesday, is this, graphing the function. So if you feel like maybe you wait till the last minute to study for all of this, you could just tonight just focus on this, and then if you end up then want to just study on part 2 tomorrow, then you can do that if you want it. If you feel like you're cramming them. It just, okay, so it's up to you. By show of hands, I'm going to go through. Now, this is what I think they wanted to focus on. First period, that's what they, but you guys can look at whatever. Of these four, what do you want to start to, we can start to look at pretty much anything, but what do you want to focus on more than anything? Yes. Transformations of given parabola?
Yeah. This is more. I just want to make sure.
Okay, so let's look at one of those. We'll start with one of those. Okay, I'm going to use an example right here. Perfect. Let's describe what's going on. Now, this is compared to, first off, of course, all these transformations are being compared to what function? The parent function. Good. So y equals x. So this is the parent function. Okay. So this guy here, this is your A. Okay. What he deals with is just the shrinking, stretching, and the reflecting. In fact, I think I have a slide that's even better than this that talks about each one. Let's do this because it's nice. It's all color coded. We can go back to that one. So I'm sorry to switch over, but here's one where wait. You want to look at one where they give you the equation first?
Yeah, sure. Is this just like?
You have to know both ways. So sorry. We'll start. Okay, they give it to you, and you have to describe the transformations. Okay. So, what's one thing you could say?
1/3, like A equals 1/3.
Yeah, A is 1/3. That's true. A is 1/3. Okay.
And we go and it's up 2 or the. I don't know.
Let's first write what you want to do is you want to write the form. Let's write the form. What is vertex form? This is why you have to have it memorized. Vertex form is y equals a x minus h squared plus k. Okay, that is one you have to have memorized. Okay. So let's complete. You can complete what you know here. So a is 1/3. What is h?
H is 2.
H is 2. You have to be careful about that. And then k is what?
4.
It's positive 4 because it's plus k. Okay. Now let's describe what's going on in this transformation. Can anyone give me something here? Okay. Okay, so that's not really a transformation of the parent function because the parent function starts concave up. Remember, the parent function is just your basic parabolas of vertex at 0, 0.
It's compressed because A is between.
Yes, good. Because the absolute value of A is between 0 and 1, so good. So this is vertically compressed or shrunk, whichever word. Vertically shrunk
So to know.
by a factor of 1/3. That's one thing. What's another thing we could say about this? So, have we taken care of everything that involves A? What about if A is positive or negative? What does that mean?
It's concave down.
Yeah, so if A is negative, it's concave down. But we're talking about transformation. We're talking about either it reflects, either this parent function to get to here reflected in the x-axis or it doesn't. Now, would it reflect? It would not because this has an A value of 1, of a positive. This guy is still positive. There was no reflection, right? So we don't have to state it. But I'm going to go ahead and state anyway, there's no reflection, just to be clear. There's no reflection in the x-axis. Okay? And then what about horizontal translations or vertical translations? What's funny? The word translations? Sound funny? Easily amused, that's not a bad thing.
You see how I went up with someone bring it?
What's that? Sure. All right, so does anyone, so we have no one say anything, which is kind of scary, a little worried, a little concerned. This guy horizontally translates.
Go right.
How do you see that? How do I know?
This guy right here. The H.
Right.
Yes. 2
My friend
units.
was saying that this whole time and you hear.
I listened. I heard you. I wanted to see if anyone else would agree or disagree. 2 units to the right. Thank you, Diamond.
That was my friend.
That was your friend. Okay. And then vertically translates.
Those are easy. You should get an algorithm for that.
Yep. Vertically translates what?
4 units left.
4 units up. Thank you. And that takes care of everything. All you have to know.
When we do it,
Yep. Just that. There's going to be there's no horizontal compression or stretching. We just have vertical stretching or compression, or shrinking, if you want to call it. Reflecting or no reflecting. Horizontal translation and vertical translation. So if we look at a problem like,
So it's not going to be on multiple choice.
correct.
it's right.
So if you have this example here where it's given, now this is another part of the test, where it gives you the transformations and you need to write it. Okay? What you need to focus on is this. This is the form that you want to use every single time. Please don't talk. You want to use the vertex form. So translated 8 units right, 2 units up, vertically compress or shrink by a factor of 0.5. 0.5 is A, H is 8, and K is 2. And that's
How do you
it.
know if it's vertically or horizontally?
There is no horizontal compression or stretching on this exam.
Oh.
And then if it had one more thing that said, and reflected in the x-axis, you would just make this negative. Negative 0.5.
Alright, now you should do another one.
Okay, so we only have a few minutes left. So let's see. Talked about these. And that was that. Let's go to here. Talked about this one. Here's another one. If you want to attempt this, see what you get. See if you get it right. This is a fantastic opportunity to quiz yourself to see how well you're doing. Translated 3 units to the left, 4 units down, stretched by a factor of 7, and reflection in the x-axis. Let's see what you get. The first step is to write this down, write it in vertex form, and then go from there. Is everything okay, Jamie? Yeah, you're trying to come up with the function. Sit down. Quit doing that. Sit down. Sit down. Last nerve, man. This is what you should have come up with.
Wait on, man, I'll finish.
What's that?
I'm there.
Sorry, we only have about 1 minute left. So,
I get my pass.
stretched by a factor of 7, and then it's reflected to its negative 7. Because it's 3 units to the left, H is negative 3, and because it's 4 down, it's negative 4.